Finally, we can go ahead and visualize the data. So in order to visualize the soft data, we are creating a empty figure with one row and two columns. And we are getting the spatial plot extents from the grid. And the reason we are doing that, I'm going to demonstrate actually. It's just going to be easier to show. So I'm just commenting out anything related to xlim and ylim. For this loop, we are iterating over the domains in our soft composites dictionary and the axis. So we have the name, the data frame of the soft data, and the axis that we want to add the figure. In our parameter file, we have this main section function, which I can kind of explain after we generate the plot. But what it takes is the data frame, the soft data column, which is the column we are plotting, we are visualizing. We are adding the grid, the color for plotting the grid. We are adding our wireframe, the shell. We are specifying the axis. So the first time we iterate over this loop, it's going to be the first column, and the second time is going to be the second column. The first time is going to be for the outside domain, and the second time for the inside domain. And we are setting the title of the plot to the domain name. Let's run this cell and visualize the result. So the result is showing here, as I said, one row, two columns, the outside domain, inside domain. We can see that the composites are added and colored by the soft data column, which can be true or false. If it's true, it's soft data. So for the outside domain, the blue is the hard data and the orange is the soft data. And for the inside domain, the blue is the hard data and the orange is the soft data. The grid nodes are shown with the gray color, and the trace of the wireframe is added by that function. You might have noticed that the plots look like to have different scales and different axis limits. And the reason is because the primary data that's defining the axis, the automatic axis or limits for the plot, are the composites. And because the inside composites is much more targeted at the middle of this area, then there is a discrepancy on the limits of the plots. So if I want them to look similar with the same limits, so it's easier to compare, then we can specify x limits and y limits. And one easy way to get good values for these two variables is to use the grid dot all extents. Spatial extents will not have a little buffer that we use when plotting, and that's why we have this other function which is called the spatial plot extents, which adds a little buffer. So the result of this function is a tuple with array of minimum and maximum value for the x-axis and y-axis. So we just capture that on this output. X-lim is going to be these two numbers, and y-lim is going to be these two numbers. And we go ahead and pass that to the function, so that when we generate the plot, the two plan view sections, they do have the same extents in x and y, so it becomes much easier to compare the location of the composites. Let's now take a look at the parameter file where we have this function to see what that function is doing. So we have here the function named main section, which takes the composites, variable, grid, the variable for the grid, a solid, the axis that we want to generate the plot for, some more keyword arguments for plotting the grid, and some more generic keyword arguments. So let's see how these things are used. So it starts with defining the size. So the size of the scatter plots for the composites, if not defined by the user, that is set to 5. Otherwise, if the user defines, then it's set to whatever the user have defined. The first part here is adding the composites to the plan view section. For the variable we have selected, in this case, we selected the soft data, so that gives the true or false blue and orange coloring. We have hard-coded the figure size in here. We have tolerances for the composite set to 5. We have the coordinate of the section set to the main coordinate, which is another parameter defined in this file. We have added a label for the composites. So as you can see, it shows. We're specifying the Z order. So the Z order just helps us control what is on top of what in the plot that we generate. So if the composites are below the grid, for instance, we wouldn't be able to see. So this is just to make sure that the composites are showing on top. Edge color is set to black. Line width is set to 0.5. The axis is coming from the provided parameters, and any keyword arguments that the user adds here as an additional gets also passed to this function. If a grid is provided, then the grid is also added to the cross section for the grid variable at the same coordinate. And we define a label for the grid, and any additional arguments for the grid is also passed to the section plot draw. And lastly, if a solid is provided, then a solid is also added to the same section using section plot draw with the same axis. We do define the trace color to be black. We use the same coordinate because we want to plot the same section. We define tolerances as 0, so we just see the traces. And we define the trace label in order for the solid to be shown in the legend. We control the line width to be 1, and we finalize the figure by adding the legend. So this function is used throughout the workflow to generate this cross-section for various variables that we might encounter or calculate or simulate or estimate within our workflow. So let's see now how to export the output of the results of this workflow for us to have access to it in the next step.